This is 7.2. And remind me, what sort of pattern does an arithmetic sequence have? Plus or minus. And geometric? Multiply, or I guess it's kind of multiply or divide, but we only use multiplication. And we do that because it makes the equation a little bit easier to use. So in this case, it says we have an arithmetic sequence, which means we're going up or down by the same amount. And we have 18, 25, 32. So we find what is called the common difference. So the difference between 25 and 18 is a plus 7. And then the difference between 32 and 25 is a plus 7. So we're going up by 7. The next two terms would be 39 and 46. Easy enough? Okay. What's the pattern here? It's plus 7 again. And we're in the negatives, which is fine. Negative 25 plus 7 is negative 18. Negative 18 plus 7 is negative 11. What would the next term be? Negative 4 and then 3. All right, this is a little bit tricky. In this arithmetic sequence, I know that a sub 1 is 2. And then I have a whole bunch of terms, and I want to know what is a sub 20. I do know the common difference. So the pattern is plus 5. So here's one way you can do this if you can't remember the easy way. You take 2 and you do plus 5. And that's a sub 2. Plus 5, a sub 3. Plus 5, plus 5, plus 5, until you get to 20. That will work as long as you count correctly. All right? Is there an easier way to do that? How many plus 5s are there going to be? Right? Right now, we are already on day 1. And at the dawn of every day, we are going to add 5. How many plus 5s occur between here and here? 19. So if I were to count all these up, there would be 19 of them. So all I need to do is 19 times 5. Oops. So 19 times 5. What does this number represent? Is this a sub 20? Not quite. Right. This is how much I need to add to term 1 to get to term 20. So this is all of the common differences added together. So I need to add that to the original 2. So I add 2, and that is a sub 20. Everybody okay with that? Okay. Same basic idea. The format's a little bit different, though. My common difference is 7, and a sub 1 is 8. How many terms is it going to take to get to a sub 78? From here to here is 77 days. Each day has a plus 7 on it. And we have to add that to the original 8. And that will give me the 78th term. Okay? We good? Okay. Is the first sequence arithmetic? Yes. What's the common difference? Plus 7. Okay, the second one? Minus 5. So it is arithmetic. The next one? Not arithmetic. Do you see a pattern? Times by 5. So that one is geometric. All right, this is a little bit tricky. So, a sub 10 is 72. D is 4. What is a sub 80? How many D's happen between 10 and 80? 70. So we need to multiply 70 times 4. And then what do we do with that number? We need to add it to 72. So on day 10, we're at $72. Every time we wake up in the morning, we find $4 sitting on the front porch. That's going to happen 70 times. And then on day 80, I will have 70 times 4 plus the original 70. Well, not the original. Plus the amount of money I had on day 10. Okay. Explicit formula. So look up on my arithmetic sequence sign right in the middle. This is just the linear equation. The explicit formula is just the linear equation. It's y equals mx plus b. So y equals mx plus b. Remind me, what is m? Slope. And what is b? The y-intercept. So there is one difference here that's a little bit confusing. When we're dealing with arithmetic sequences, we change the formula and we say that a sub n, and whenever you see the variable n, okay, I'll give him your tardy. So whenever you see n as a variable, it means it's a natural number, like 1, 2, 3, 4, 5. If you see x, then it could be anything like 1.5 or the square root of 2. But for the most part, when you see the variable n, that means that it's a natural number. A sub n is d times n plus a sub 0. And this equation means exactly the same thing as this equation. Okay? So a sub n equals dn plus a sub 0 is exactly the same as y equals mx plus b. But there is a little bit of a trick. Do you notice anything weird about this equation? Yeah, it's a 0. This. Okay. On which day does the y-intercept occur? Day 0. But sequences begin on day 1. And that's a little bit strange. Okay? So that's something you have to remember here. If I want to fill out this formula, then a sub n is going to be, what's my common difference? Negative 6. So negative 6 times n plus what? Good job. So day 1 does not get plugged into the equation. Day 0 gets plugged in. But day 0 is not part of the sequence. But when you do a linear equation, the y-intercept is part of mx plus b. So when you're dealing with arithmetic sequences, you have to remember this number here is whatever would occur before that number. So we need to add 6 to it to get 34. Oh, yeah, they did it the hard way. We don't want to do it that way. All right, let's do another one of those. Okay. So my formula, a sub n. So a sub n just means it could be any day. It could be day 1 or 7 or 8 or 10 or 15. So the common difference here is 7. They like the number 7, don't they? So 7n, and then what? Minus 1. Does everybody get that? So what would happen right here? And the answer would be negative 1. Okay, let's do another one. What's the pattern? Plus 6. So 6n, and then what would occur right there? Negative 31. Does that make sense? Okay. All right. Let's stop there. This is called an arithmetic series. I think your brains might be full. So when you get to the add together ones, you can stop. Let's see what else is left. Oh, just that? Never mind. We're going to do it. If it's only one question. Okay. Have you ever watched a movie and they had a really nasty mathematical equation up on the board and you're like, oh, that's really advanced? Well, you probably saw something like this. Okay, that big E is a Greek symbol like pi, alpha, beta, gamma, delta, epsilon, zeta, eta, theta. This is a sigma. It's the S of Greek. And so the reason they use sigma here, it's an S and it stands for summation. And in mathematics, a sum is the answer to an addition problem. Okay, so all this is an adding machine. And it's just a set of instructions. So here is my explicit arithmetic sequence formula, right? 4x minus 7. And it says, I want to add the sequence together. So the sequence is 6, 9, no. Oh, these are different formulas. So this says, start with the number 1 and keep plugging in numbers until you get to 101. So if we plug in 1, we get 4 minus 7 is negative 3. If we plug in 2, we get 8 minus 7 is 1. If we plug in 3, 12 minus 7 is 5. And then the next one will be 9 and 13. And we're going to keep doing it until we plug in 101. Okay? That is a sequence. A set of numbers separated by commas is called a sequence. But a lot of times, we want to add these together. And when you add them together, you get what is called a series. So a sequence tells you how much money is in your bank account every day. You started at negative 3. Every day, your secret admirer deposits $4 in your bank account. So day 1, you're $3 in the hole. Day 2, you have $1. Day 3, you have $5. Okay? And then the series would be how much money you would have if you added all of those days together. Okay? So how do we do that? Does anybody actually want to go through and add all that up? No. So there's a really easy formula. Let's take something small. So let's do 6, 8, 10, 12, 14. Okay. So day 1 I get paid $6. Day 2 I get paid $8. And then 10, and then 12, and then 14. How much money did I get paid in total? Well, it would be 6 plus 8 plus 10 plus 12 plus 14. But watch what happens when I, let's do one more. So 16. Watch what happens when I link the ends together. 6 plus 16 is 22. 8 plus 14 is 22. 10 plus 12 is 22. So if I draw a line here and I flip these numbers over, then I get 22, 22, 22. Right? How many 22s are there? And 3 is half of the numbers that are there. Right? So the total is simply 22, or the first one plus the last one, times half of the amount of numbers, right? And that's going to work every single time. So the summation formula is n over 2 times a sub 1 plus a sub n. And we actually call this s sub n. So if you want to know, if you know how much money you made every day, if you want to know the total amount of money, you don't need to know the value for every day. All you need to know is how many times did you get paid, cut that in half, and then take the first number and add it to the last number. And that will tell you your total amount. Okay, so in this first one, I'm going to take, I need n times a sub 1 plus a sub n over 2. I already know the first number is 6. And I know that the last number is 240. Okay. How many numbers are there? Huh? How come? You're really, really, really close. Okay, what's the pattern? Plus 3. So plus 3. Okay. What's that? Nope. Your process is really close, but we need to figure out what is the difference between this day and this day. So we take 240 and we subtract 6, and I get 234. What does this number represent? It's all of the D's put together, right? How big is each D? 3. So we're going to take 234. So we take 234 and we divide it by 3. What does that tell me? That's how many D's we used. If we used 78 D's, when did we get paid? What was the day that we got paid the last time? So if this if this here is a sub 1, and we did plus 3 78 times, then this must be a sub 79, right? So this number is 79. Okay, now that's the hardest thing you're going to do today. This one is much easier. So, how many days are we adding together? 101. So 101. How much did we get paid on day 1? Just plug 1 in. 4 times 1 is 4, minus 7 is negative 3. How much did we get paid on day 101? Just plug in 101. 4 times 101 is 404. Minus 7 is 397 over 2. Okay, I think we need to do a couple of these. What do you think? All right, let's do the summation one first because it's the easier one. So 131, that's how many days we're getting paid. Plug in 1. Negative 5 plus 11 is 6. Plug in 131. I don't have my calculator handy. So negative 5 times 131 plus 11 is negative 644 over 2. And then just plug that in your calculator. And that will tell you how much money you make. Does everybody understand that type? Pretty easy. Okay. All right. Now the other type. What is our common difference? Minus 2. So our formula is n times the first day, which is $1, and the last day, which is negative $217 over 2. So now we need to figure out how many days there are. To find that, I take this value and I subtract that value. So negative 217 minus 1 is negative 218. So the difference between how much I lost the last day and the first day is negative 218. What do I do with that? I divide it by the size of the difference. So I divide it by negative 2. And I get 109. What does 109 tell me? How many times I subtracted 2? So I did minus 2 109 times. If I did minus 2 109 times, which day is represented there? 110. So this would be 110. Does that make sense? Do you want to see another one? Okay, let's say we had 65 plus 70 plus 75 plus 295. So the formula is going to be 65 plus 295. All I need to know is which day is that. So I take 295 and I subtract 65. So 295 minus 65, oops, is 230. So right here I have plus 5, plus 5, plus 5. If I add up all the plus 5s, I get, oh, I wrote 200, but it's actually 230. Okay? So all of my plus 5s add up to be 230. So if I take 230 and I divide it by 5, that will tell me how many plus 5s I did. So we divide this by 5, and we get 46. So there are 1, 2, 3, 4, 5, 6, 46 plus 5s. And if I started on day 1 and I did 46 plus 5s, this day would be 47. Do you want to see another one? We good? One more? Okay, let's do another subtraction one. All right. Let's do 84, 80, 82, or sorry, 76, negative, let's do negative 68. So my pattern is -4. My equation is going to be something times 84 minus 68. Okay. How far is it from here to here? How much did I drop? So if you want to find distance, you always take the latter number and then you subtract the first number. So negative 68 minus 84, and I get 152. So -4 minus 4 minus 4 minus 4 equals negative 152. So all of my negative 4's put together equals negative 152. So I take negative 152 and I divide it by -4, and I get 38. So there are 38 -4's. And if the first one happens after day 1, then this must be day 39. So 39 over 2. Now, this number is actually not very big. So 39 times 84 minus 68 divided by 2. This number is only 312. If I'm adding such big numbers together, why is 312 so small? No, it's not the division here. The negatives are canceling out the positives. Right? So we had 84 plus 80 plus 76 plus 72. And now I'm getting a really big number. But once I get below 0, I start subtracting. So this sequence kind of cancels itself out. So most of the value in the numbers has worked itself out of the formula. All right, that's it. 7.2. Get to work.